This is the configops component using step 6 to finish off our coding for the various functions in our configops. Let's go ahead and take a look at the code. Again, we've got our steps 1 through 4 in the main program done, and there's just no good reason to go back and look at the main function again. You know it works, you've tested it with your just different print string items here, and we've brought this through. We have also fleshed out this part right here so that you'll get this on your output. When we bring this up right here and we press enter, we know we get that part, so we've tested that. We take the simulator program end. If we've set up anything else in here with, say, for example, a dash DC or a dash DM or dash, let's say dash RS with config 0CNF, then we have run sim called here. We've got that in. So we just don't have to go back to anything. We will write that function sometime later. Now I need to note here that what I'm doing here in this file, because I'm having to do this in Windows, the video, it does not work terribly well with the online Linux stuff. And so I'm having to do this all in one file. The reason I'm doing it in one file is so I can guarantee you that all this code is working. If I tried to do it in multiple files and move things around, there might be something missed. So in this case right here, I'm doing it all in one file, but you must do it in separate files. The other thing you'll notice is that we're going to do these in alphabetical order. Cool thing about step 5 and 6 is that once you've got to the point of knowing what your functions are and specifying them and designing them, there's just no reason that you have to do them in any particular order. You could, in some cases, say, oh, hey, I just want to get the display function going first. That's fine. Then you would want to do that. Otherwise, I'm just putting them in alphabetical order, and you should too. When we were first designing these in step 5, we just did them as we ran into them. But now that we're getting into step 6, I have gone ahead and organized them in alphabetical order so that I can find them a little bit easier. These are going to be long files. This is your configops.c if you're using that, but one way or the other, it's going to be a pretty long file, and you're going to find that it's a little easier if they're alphabetized. Let's look at clear config data. This is not all that different from the other one for metadata, but it is a single thing instead of multiple things. So we're going to just check for not equal to null. This is a key point because just in case this gets called and the data has not been allocated, you do not want to try to deallocate non-allocated data. That will break. But I want to check that for not null first. If it's the case, I'm going to free that config data. It's just one memory allocation quantity of one struct. And then I'm going to set that pointer to null, and then I'm just going to return null to whatever pointer was pointed here. Both of these settings to null are just ways to keep people from trying to use pointers later on that might not, in fact, after this one, will not have any data associated with them, any legitimate data associated with them. We can take out our temporary stub return, and we can move on to the next function. The config code to string function is very simple. We're going to start by defining an array with these items in it, these string items in it. And then our number that's coming in with the code, we've made sure to align them with what they are aligned with in the data structure. And let's take a look at that. Here is the configops.h file here. We've got some out of range and some different kinds of error codes and messages here that you're going to be seeing a little bit later on as we start going through the codes here. The string manip code goes up to 0, 1, and 2. This starts at 3 right here, and you can do that in an enumeration quantity. So we don't step on the string manipulation code when we want to use the same return output from a given function to get any of these messages. So this is messages are coming out of that, which we will see in a little bit. And then these are my SJF, SRTF codes. I've enumerated these. And what that means here is that SJFN is at 0 right here. Well, it turns out that's exactly what this will be. SRTF will be at 1, and that's what I've got there. So I've aligned them with my codes here. So if somebody calls with one of these codes, they can just call it CPU sched SJFN code. Out of this converter right here, they will get the string. So with that in mind, we just copy the string right there into the out string, and that's going to be passed back out as a parameter. Not much to it. You'll see this in use a little later. And now it's a little bit later. You'll get to see this actually go to work that you just looked at. So we'll start with this guy right here. We'll get a display string that we're going to output here in just a moment. This is a display operation, so it's okay to do output. And what we'll do here is we'll set up, we'll print our file display with the underline here. We'll print our version with our config data version. We're bringing that out of here. Our program file name is all in here. We have to do that config code to string to set our CPU sched code to the display string right there, and then we will be able to display that. So that's what that was for, that we just created. We'll do the quantum time, we'll do the memory available, process cycle rate and IO cycle rate, and then again we have to do the config code to string for the log2 code. The log2 code itself is right up here. It's in this other enumeration, and so if somebody calls with this, we're going to get the right thing out of it there. So that's going to come out of the log2 selection as well, and it gets displayed from the string there. And then we're going to do the log file name, which is also in the config data, and that will take care of displaying this. Now again, this is a requirement for purposes of displaying it from the command line, but it's also awfully handy as a diagnostic tool if you find yourself just needing to find out, hey, what have I got and what don't I have when I'm setting up my config. Let's go to the next one. Now our get config data function is a big boy. We've got a lot of things we're going to get out of this, but we're going to bring the whole thing in here, and when we get done, we're going to pass the pointer of the config data back by making it a double pointer to send it back through the parameter. And then the Boolean will simply tell us that we succeeded or failed. The end state message will also say, here's what went wrong, as needed. We come in here, we're going to initialize our variables. Num data lines is 9. That just kind of helps limit what we're going to do here. Set our read-only flag there. Create a pointer for the data input, and we'll be managing that a little bit later. And we'll declare some other variables. We have a file access pointer and that kind of stuff. All right, so we're going to start by saying, hey, everything's good. We'll plan on that being the case unless we change it. We'll initialize this guy to null just in case something does go wrong, and we'll pick him up and give him some data a little bit later on. We will open the file. And if the file opens correctly, then we're good. But if it fails, then we are going to have to set the end state message to a failure, and we'll have to return false from there. We'll get that first line, and once again, we're stepping our way into this. Did it open okay? Now, can we get a first line here? So we're asking, are we getting the start simulator configuration file that we find in the config file right here, this part right here? Are we getting that? And if we don't get that, then we'll close the file, tell it what happened, and return false. Now at this point, we've at least made it into the file and we're getting data. So we've got a little bit of trust here. So we will go ahead and create the memory necessary to handle this thing. We're going to loop all the way through all of the data that we're going to find, remembering that as we look at this, any of these could be in any order. Quantum time could be first, processor cycle time could be last. They could be in any order. So we're just going to loop through and see what we find as we go along. So we're going to go to the line leader, and that's just this part right here, whatever is the leader for each line. Go to the line leader and get that line. We're going to check it and say, okay, did we get something that we're supposed to get? And have no errors here. And so if we did, if not equals no error, we did find an error, then we will free that memory, close the file, tell it what happened, and then return our false. But if we made it this far, then we will go ahead and get the data line code. Now remember that get data line code takes in the data buffer, and that's the string we just collected. And that data buffer is going to convert that into a number. It will get the number for a given line, and each number is associated with each line for what we have. There is a number associated to file path. There is a number associated to CPU scheduling code. There is a number associated to quantum time, and so on. So we're going to get that number. We're going to check and see if we got it, because if we did, then we can move on ahead. Didn't get a corrupt prompt. We'll get the data value itself. And that's where we're going to reach in there and say, in fact, we've got to try different things, because if it's a version code, it's going to be a double. If it's a couple of other things, it's going to be integers or it's going to be a string, and we'll see those in a moment. But for the CFG version code, it's a double, so we're going to take in double data here. So when we come down here, we're going to check all these. Any of these could come in as strings. So since they would come in as strings, we have to fscanf them as strings. All right, otherwise, all the rest of the choices here are integer data, so we will take in integer data. Now our next step here is we've taken in some data, and now the question here is it in range? And remember, our data line code will say, okay, it's memory available, it's process cycle time, whatever. Memory available is allowed to go from 1024 to 102400. Quantum time goes up to 100, I think. There's different constants on this that you'll see in your assignment. But nevertheless, value in range is going to figure that out. If we are in range, then we're going to go ahead and set up our assignment for wherever it goes. And remember, counting on data line code to figure out which one it is, we'll put a bunch of stuff in here, and that is okay. It's version code, set it to there. If it's a file name code, set it to that. If it's a sched code, put it to there, and so on. So all of these are just nothing but tests and operations, which we could have filled in the step 5, but as I mentioned at that time, some of these you just go through the list. We have our list right here of things that need to be put in, and we just fill them in and just take what we're going to get out of it. Because different things do different ways. This is going to be a copy string because it's a string. This is an assignment. Each one of them is assignment to a different thing: sched code, quantum cycles, mem available, and so on. So we do that. Now, assuming that we made it through that okay, value was in range and we got those things, we're good. But if we're not, we didn't get that, then if something's broken here, we're going to have to start over here. We're going to have to free up the temp data, have to close the file. We'll copy it and say some configuration item is out of range, because that's what this guy right here told us here. And then we will return the faults out of that. And if we did not find a good data line, then again, we got to shut everything down, free the data, close the file, copy the string in specific. This is handy because each of these things is kind of trying to tell you what broke on this right here. My increment line counter here is going to come back in under this master loop that we started with while we're counting up to the number of data lines here. So having done that, we have now been through it 9 times. We should have found 9 items, not necessarily in order, but it will find all of them and put them in the right place. And if that's okay there, we will acquire the end of the sim config string. That's got to be correct. When we look down here, if that's not correct, we're going to end it with a period here, so that keeps us from having to put a period on here. But we're going to end that, and if this comes through here we ended at the period here. If this comes through and this is not correct, then we'll go ahead and shut everything down again, free the memory, close the file, tell us exactly what happened here, and then return false. Otherwise, we're going to take that temp data pointer and assign it to a pointer to the temp data pointer, so that can be passed back as a reference parameter, as a config data type here, config data pointer. And then we can really close the file for success, and we'll return the true error code, which in this case would be, in fact, true. We had no errors. Let's move along. This function is going to do kind of comparable what we did a little while ago to translating things, but we're going to do whatever the string part that comes through here, we're going to turn it into a code number. Again, the code number that we found up above here. So let's go ahead and get started. We'll go ahead and set a strlen to the length of the code stir here, and then we will malloc enough space to put that in there. We'll set the default to FCFSN code. This just cuts off another line or two of code at the end. We'll just set the default and fall through to that. There won't be any failure mode here on this one. All right, so the next thing we're going to do is take that string and run it to lowercase so that we know we won't have any case problems when we do our comparing. And from here on in, it's a lookup. If it's SJFN, we'll return that code. If it's SRTFP, we'll return that code. If it's FCFSP, we'll return that code. If it's RRP, we'll return that code. And again, if it's none of the above, it will be the FCFSN code. Once we're through with that, we've used this temp string for all we need. We give back the memory, and then we return the value that we searched for. And we can take away our temporary stub return. So just a lookup. There's not much to it, but this is the kind of code you do not want in the middle of your main program or any of your main functions. This is a utility that you want to have set aside. Let's move to the next one. Now remember, each of these, what I call leaders, have to be exactly correct. If any of them are misspelled or there's any problems with these, then it's not supposed to work. It's supposed to shut itself down. So what we've got now is a function that says get data line code and verifies it. Okay, and this is another lookup. It's just not a big deal here. If it's a version phase, which we see right here, it should be that. If it's that, then it's going to return the config version code as specified here in our enumerated quantities here. So it's going to return that. Then if it's a file path, it's going to return that code. If it's CPU scheduling code, it's going to return that one. Quantum time, it's going to return that. Memory available returns that. Processor cycle time returns that. I/O cycle time returns that. Our log2 time returns that. And then our log file path returns that. And so that's just all of our tests. It's really nothing but a lookup, but it converts strings to numbers that we can use, and storage is a lot easier to handle. We'll go ahead and return what that was right there, and we can take away our temporary stub return. Again, not a lot to these, but when you build these functions out as utilities, sure saves a lot of messy code in your main code, in any main code, in any function, but it also makes sure that you do a good job here, less opportunity to make mistakes. This is almost exactly the same process, only if rather than bringing back config codes, it's bringing back the log2 codes. There's three choices: file, monitor, and both. This function has no failure mode because it's going to assume it logs to monitor if nothing else works there. So let's go ahead and set this one up. We're going to set up our string length. This is exactly the same thing we did before. Log2 string here. We're going to default it to log2 monitor code. We will set it to lowercase so we don't have problems with comparing characters. And then from there on in, if it's both, we do a log2 both code. Again, coming back up to our config ops, log2 code, and so on. And then we'll come back here for file. If it's file, we'll set log2 file code. And we got that. And then we'll come down here. We can free up the temp stir. We know that the log2 monitor code is going to be the default. And then we can return that return value and get rid of our temporary stub return. Let's go to the next one. This is another one that's basically another lookup, but it's a little bit more complicated. This is one that's going to look everything up by item, by whichever item is in config, but it's going to check its number or its limits and figure out if that's okay and return a Boolean on that. Let's jump in. We'll set a couple of variables up here, including the result to be true. We'll assume positive until proven negative. All right, so we'll set our switch to line code. This is going to be jumping across all of the possibilities. For the version code, we will take a look and see if it's outside or below 0.0, above 10.0, and set it to false if that's the case. And then we will throw in our break for our switch here. For the CPU scheduling code, we have to create a temporary string for this right here and set it all to lowercase for testing purposes here. We will check these strings right here, and if it's in none of these guys right here, we will go ahead and set that to false. So we'll free up the string that we created at that point, and then we will break after that, and then we'll come to the quantum cycles. And again, we're using these codes here that we just actually put together in a previous function. So we will check for the quantum cycles limits exceeded. If that's a problem, then we'll set these to false. All of these specifications will be provided in the assignment, so you have a backup on this. We'll break out of that. For memory available, we'll check for the memory limits. Again, 1K up to 100K is what's allowed. If it's outside that, then that's going to return a false. We'll break out after that. We'll check for process cycles here. And when we get into that, we'll say, okay, you can be 1 to 100 here, but if you're outside that, it's going to be false. And we'll break out of that. Then we'll check for our I/O cycles. This is allowed to go from 1 to 1,000, although hopefully we'll never go there. That's a long time. But if we do, it's allowed. And so, but if it's outside of that, they'll get a false. And then we break out of that. And then we check for the log2 out of that. And for this one, we'll have to create a string. We will compare that to the three possible and correct operations here for your log2. And if they're not one of those, then that's a false as well. And last but not least, inside of this one right here, you'll have to free that string memory. And of course, you'll break out of that one as well. That's about it. We're going to return our result right there. And again, kind of a lookup, but it's a little bit more complicated because it's looking up each item to make sure that it's all within the specifications. So, and I repeat myself, you will have these numbers here, but you should take a look at the numbers in the assignment in case they get changed. So that is all there is to config ops. We can wrap this guy up. This was our config ops video that used step 6 of filling in the blanks. That's what's really cool about the 6-step programming process. Your step 5 said step by step, here's how to do it. You wrote it in text. You didn't have to fix code when you changed things. You just line by line said this has to happen. And then when it came time to do the coding, you really just filled in blanks. And for purposes of your 200-line code programs, that you might do for 249 or for other places, it's not as critical. But for this right here, this is going to be several thousand lines, at least a few thousand lines before you get done. Because this is all we've done with configops, and also we'll be doing a metadata ops is 1,000 lines or so, but you're going to have the run simulator, which is going to expand the whole mess. So with all that in mind, we can go ahead and wrap up configops step 6 and move on.